Every single time your phone connects to a 5G network, something pretty wild happens in, like, less than a second. It's this hidden, super high-stakes digital handshake, a secret negotiation to prove who you are and build a totally secure tunnel for all your data. So let's dive in and see exactly how this incredible process actually works.
So really, what is going on in that blink of an eye? It's so much more than just finding a signal. It's this complex, almost beautifully choreographed security procedure that's constantly protecting you from digital spies and imposters online. To get our heads around this, let's meet the cast of characters. First, you've got your phone. We'll call it our secret agent. Then there's the cell tower, the first point of contact. And deep inside the network, you have the brain, which manages access, and the guard, which handles all the heavy security logic. Their one mission? Get our agent connected, safely and securely.
All right, here's our mission briefing. We're going to follow this handshake from the very beginning to the very end, phase by phase. We'll start with creating a secret identity, move to building a secure tunnel, and then, at the end, we'll see why this new level of security is such a game changer. At its heart, this whole mission boils down to one word: trust. In a world that's just full of digital threats, your phone can't just connect to any old tower it sees, and the network can't just let any device on either. They have to prove themselves to each other.
And this right here, this is basically the playbook. It's the step-by-step conversation between our agent and the network. We are going to walk through this exact flow, from that very first request all the way to that final connection complete.
Okay, phase 1. This is where we learn why a good secret agent never, ever reveals their true identity out in the open. The very first move is all about privacy. So check this out. Your phone has a permanent ID. It's called an IMSI. But broadcasting that would be like shouting your driver's license number in the middle of a crowded mall. So instead, 5G is smart. It encrypts it into a temporary ID called a SUCI. Think of it as a digital disguise, a privacy shield. This is the absolute golden rule of 5G privacy. It's a massive upgrade from older networks. By never sending your real, permanent identity out in the open, 5G just shuts down an entire category of tracking and surveillance attacks right from the get-go. And now for the climax of our little spy mission, the trust challenge. So the network has this disguised ID, but now it's time for the moment of truth. Both sides have to prove they are who they claim to be, and this is not a one-way street.
This whole process is called mutual authentication. And what that really means is your phone needs to trust the network, and the network absolutely needs to trust your phone. It's like a digital, show me your ID and I'll show you mine, and it happens automatically, every single time you connect. So here's how it starts. The network's guard sends a challenge to your phone. It's basically a random number and a special token. You can think of it as a secret question that only the unique key baked into your phone's SIM card knows how to answer. But here's the really genius part. That token doesn't just have the question, it also has a secret signature from the network. This is how your phone can be 100% sure it's talking to a legitimate cell tower and not a fake one set up by an attacker, what some people call an IMSI catcher.
So your phone gets the challenge. It uses its secret key to do some complex math, and it calculates the correct response. It sends this answer back to the network. If the network's calculation matches your phone's answer, boom, authentication is a success. Trust has officially been established.
All right, trust is established. Now it's time to build. Phase 3 is all about creating a private, encrypted tunnel so that all of your communication from here on out is completely shielded from any eavesdroppers.
And this is the real aha moment. That successful handshake doesn't just open a door, it forges a master key. And from that one single key, a whole family of other keys is created. And each one has a very specific job to do. Some protect control messages, others encrypt your actual data. It's incredibly robust.
The network then sends what's called a Security Mode Command. This tells your phone exactly which encryption recipe to use. And get this, for a clever anti-tamper check, it also repeats back the security skills your phone said it had. If a man-in-the-middle attacker changed that list, your phone would know instantly.
Your phone sends back a Security Mode Complete message, and just like that, it's locked down. The secure tunnel is up and running. From this exact moment on, every single thing sent back and forth is fully encrypted and protected, making it totally unreadable to anyone else. We are in the home stretch now. Phase 4 is the final confirmation. The doors are officially open, and your phone is granted full access to the network.
The network sends a registration accept message. Now, what's really cool here is it gives your phone another temporary ID for even better privacy down the line. It also hands over a slice ticket. Think of that as your VIP pass. It tells the network what kind of services you can access, like maybe a high-speed video slice or an ultra-fast gaming slice.
And with one last registration complete message from your phone, that's it. It's officially in a registered state. It's now ready to hit the internet, make calls, or just go into idle mode to save some battery, all while staying totally secure.
So after all that, you might be wondering, why does this all matter? What's the big payoff? Well, it's because this whole process represents a massive, massive leap forward in mobile security.
I mean, just look at the difference here. With 4G, your main identity could be sent out in the open. 5G? Nope, it's always encrypted. In 4G, the security key system was simpler. In 5G, it's separated into different jobs, which is way more secure. The bottom line is your privacy goes from just medium to high. These are not small changes. These are fundamental upgrades.
And with that, our mission is complete. Let's just run through the final checklist. Did we protect our agent's identity? Yes, with that SUCI disguise. Did we verify the network wasn't a fake? Check, with mutual authentication. Did we build an encrypted tunnel? You bet, with security mode. And did we manage access and privacy for the future? Check with the temporary ID and slicing. Mission accomplished.
This complex, totally invisible handshake happens billions and billions of times a day, and it forms the very foundation of trust for our entire connected world. It kind of makes you wonder, right? As everything from our cars to our coffee makers comes online, what's the next great challenge going to be for securing our digital trust?